Okay, good morning. Welcome to
MinuteMath160.
Except that it's not morning. Good evening. So today we have a problem from the Mathematical Association of America's Minute Math page, and it's from, I think, the 2003 AMC 12. And only 11% of the people got this right. And you know what? You've never seen this before, so you know what?
Yeah.
I think you're going to have a hard time doing it.
Probably.
But what we're going to do is we're just going to talk about it because it's kind of a neat problem. The second and fourth terms of a geometric sequence. Have you ever heard those words before?
Yeah,
When?
but they're not in this order.
Okay, the second and fourth terms, you've heard each of the words before, but not together, right?
Yes.
Are 2 and 6. What are the possible first terms? Okay, so let's talk about sequences really quick. There's something called an arithmetic sequence, and what arithmetic sequence means is you add the same number to every term to get the next term. So 1, 3, 5. I just keep adding 2 every time. So the next term would be?
Would be 7.
The next term would be?
9.
And then?
Then 11.
11, etc. That's called an arithmetic sequence. Now there's other kinds of sequences as well. Before I say what a geometric sequence is, there's like the Fibonacci numbers that are defined by a formula where you add the prior 2 terms. 1 plus 1 is 2. 1 plus 2 is?
3.
2 plus 3 is?
5.
3 plus 5 is?
8.
And so on. And those are special kinds of sequences. This is an arithmetic sequence where the difference is always the same. Notice the difference here is not always the same. 0, 1, 2, 3, or 2, sorry. 0, 1, 1, 2, 3. It keeps changing. Here the difference is always 2.
And that's actually pretty funny. It's 0, 1, 1, 2, 3.
Yeah?
That's actually the Fibonacci numbers.
Isn't that interesting?
And 5.
Huh. I wonder why that is. Sneaky. Good you noticed that though. And then, so a geometric sequence is you multiply by the same number every time. So I might start at 1, multiply by 2 to get 2, multiply by 2 to get 4, multiply by 2 to get 8, then?
And then 8 times 2 is 16, then 32.
And so on. And that's what a geometric sequence is. So that's what we have here. So we have the second and fourth terms are 2 and 6. Okay, 2 and 6. So we start with some number, and usually they call the first term A, and they call the thing you multiply by R. I don't really know where that came from. AR. So I multiply by R. What happens when I multiply this by R? I get A.
R
squared. And
or
I
A R.
R. Pirate day. Okay, what about this third term?
Is it
Multiply
R?
by R again.
R cubed.
A times R cubed.
A R cubed. R.
R. Okay, so we have to figure out if we can fill in the gaps here. Well, we know A times R is 2, and we know A times R cubed is 6. So one thing we could do is take a ratio. 6 over 2 equals AR cubed over AR. What can I cancel from that?
You can cancel an A and an R.
And I left with R squared. And what does R squared equal?
R squared is well, we know AR equals 2.
Well, right. I said 6 over 2 is R squared. So what does R squared equal?
It equals 3.
3. So what are the possible values that R could be? If R squared is 3, R could be what?
R could be the square root of 3.
Square root of 3. Or?
Or 9. 3 squared.
Square root of 3. What's the other thing R could be? What
It
2?
could be 1. Well, you can go 1, 3.
Stop. R squared is 3. So R is a number so that when you multiply it times itself, you get 3. So one thing R could be would be the square root of 3. What else could R be?
Negative the square root of 3.
There you go, negative the square root of 3. Not 9, because 9 squared is...
81.
And not 1, because 1 squared is...
It's just 1.
1. Okay, so R could either be the square root of 3, or it could be minus the square root of 3.
It didn't say these had to be integers.
No, it did not say they had to be integers. So to go from here, remember this was a and this was ar, so I just have to divide by r. So this could be 2 over the square root of 3, divide by r. Or it could be negative 2 over the square root of 3. Right?
Mm-hmm.
So either one of these two are the possible choices for the first term, and it turned out this was what the answer was on the test. Pretty neat. So, what's an arithmetic sequence?
Arithmetic is adding the number before it.
No.
But it was adding the same number to each.
Adding the same number every time. What's a geometric sequence?
It's multiplying the same number.
Multiplying the same number every time. Yeah. Okay, good job. Good job. I never haven't seen that before.